Okay, welcome to the first of the videos for the holiday homework on the linear function. This video pertains to the chapter 7, it's chapter 7.1, and it's the distance formula. We know from our studies in the junior school that the distance formula is given by d equals the square root of x2 minus x1 all squared plus y2 minus y1 all squared, y2 minus y1 all squared. Now, it doesn't matter if you have the 1 and the 2 in this formula swapped around. It is also the same as x1 minus x2 all squared plus y1 minus y2 all squared. It doesn't matter as long as you just keep the 2 points that we are using relative to each other the same. So let's just firstly work out what this formula actually does. So here is a simple x and y axis, and if I want to find the distance between, say, this point up here, which we'll put in here, this is 0.45, and we will say 2 here. Then the distance is found by this direct line there. That distance is part of a right angled triangle, which will be formulated by going there and there. And just by simply counting the squares, we can see that this is 3 high and 2 along there. And remembering that Pythagoras' theorem says that c squared equals a squared plus b squared, and c is the hypotenuse, then it will be 3 squared plus 2 squared, which is 9, plus 4, which is 13. Therefore, c equals root 13. And this, remember, if you leave it in the square root form, that's called the exact value. Okay. Now, what does the distance formula do? It does exactly the same thing as this. All it says is, with this peculiar d equals the square root of a first bracket squared plus a second bracket squared, the first bracket here calculates that side there. And the second bracket here calculates the length of that side there. So by saying, let's remove those, first thing is here we subtract the x's. So this is subtract x. So the first value here is a 4, and this one here is a 2. They're the two x values. And 4 minus 2 equals 2. And this 2 is the same as that 2 just there. And this is the second bracket, says subtract the y's. And the y values are 5 and 2. So 5 minus 2 equals 3. And 3 is that number there. So it simply gives you an answer straight away to this final answer down here by shoving the numbers, the coordinate values, into the formula, and you get the answer out straight away. So let's just use the formula. So I'll just rub a few things out. Get some room. Okay. And the secret of using this formula is do not rush and set it out correctly. Always write the formula down before it's used, and just take it slow and do not cut corners. So writing it down, I'm just going to x2 minus x1 all squared plus y2 minus y1. Get it away. It's not going to go away. Squared. Squared there. Rightio. Equals. Okay. All you've got to do is say, okay, whichever one point that you're going to use as the beginning point, you use it as the beginning. So if we just say this is the beginning point and this is the ending point, it doesn't matter which one you use, you just simply stay there and use that and always go in the same direction. So we're going to say it's going to be the square root of 4 minus 2. So just say this x value, 4 minus 2. and it's squared. Plus, going up to the beginning point again, it's 5 minus 2, all squared. And keep that square root. 4 minus 2 is 2 squared. Now this is where you get this side here. 5 minus 2 is 3 squared. And don't forget it's a plus in the centre because Pythagoras' theorem says it's plus, not a minus. And that gives you the second side over here. So that becomes a square root of 4 plus 9, which is root 13. So that's how the formula works. It simply is Pythagoras' theorem. So, just clearing that, let's try another one. If we want to find one which has a little bit more difficulty, let's put one in the first quadrant up here. So that's 4, 5 again. We'll start that there. And down here into the fourth quadrant. And this one here is 1, -3. Then this will be the distance between the two. Okay. And we can simply form the right angle triangle like that there. And we know that the side of this triangle will be 3 in the x direction and 1, 2, 3, 4, 5, 6, 7, 8 in the vertical direction, in the y direction. So we could work it out without the formula by saying that c squared would equal 3 squared plus 8 squared, which is 9 plus 64, which is 73. So C would equal root 73. That's quite valid. It's one of the easiest ways of doing it, but you have to have a very good diagram to do that. But if we prefer not to use that, prefer to just use the formula, so I'm not going to get this eraser up, and just use the formula, it does the same thing. It's no mystery as to what it's doing. So remember, we always have a beginning point and an ending point, and we just keep the order the same. So we're going to say this is the beginning and this is our ending point. So these are firstly the x value and then the y value of the beginning and the x and the y of the end point. And it's x1 or x2 squared, doesn't matter, minus x2 squared, as long as you keep them the same way. Y1 minus y2 squared. As long as 1s go first and 2, this is just beginning and end, beginning and end. It doesn't matter what we do. So, let's do it. Subtracting the x's first, it's 4 minus 1 squared plus, it is a plus in there, it is not a minus. One of the most common mistakes is to make it a minus. And then 5 minus -3, so it's 5 minus -3, and this becomes a plus in a few moments. So the double negative here, you will now change to a positive, so this becomes a square root of, that's 3 squared plus 8 squared. And you can see these are the two sides that we had of the triangle before, that's a 3 and the 8. And just doing that, it's 9 plus 64, and finally root 73. A secret also to using this formula is to use as many lines as you possibly, not as many lines as you possibly can, but enough lines to show your working so that you don't make careless error. Right, let's go to have a look at some of the exercises that you'll be doing. So, yeah, this is the textbook. The first few questions are simply finding distances between points. So question 1 here will simply have a beginning and an end point. And this, the only difference between that and question 2, sorry, I'll just get the, the only difference between question 1 and 2 is that question 2 asks for the exact length there. So please leave it in the square root form that we need. Okay. Question number 3 is saying to 2 decimal places. So once again, the first 3 questions are simply finding the distance using the distance formula and just applying it. Okay. The next one is to prove certain things. So the next one is to find the perimeter of a triangle. And when finding the perimeter of a triangle, you will simply find all the lengths of the sides of the triangle and then add them together. So let's have a look at an example of something like that if we were to try and do it. So going back to our diagram here. If these are the 3 points of our triangle, so we have one here, one there, and one there, here are 3 lengths, then we would simply find each length one after another. So just writing in these points here, this point up here is 2, 4, and this one here is 3, -2, so that's -2, and this point here is -2, -1. So we'll call this A, and then B, and then C. And we'll find distance AC. So distance AC I'll use with this notation, and it would equal, so we're going to find this length going along here first. Okay? So just using the formula, it's subtract the x's, then subtract the y's. Starting with 1, we'll start with A and we'll subtract C. It doesn't matter which way you do it, it will always be the same. So firstly, writing out the formula, this time I'll put the 2's first. Sorry, it's gone over into my working. Okay, so I'm just going to undo that writing there, so it just takes away. So you can just assume that the working has been done. Okay, sorry, the formula has been written. And it would equal, it's going to be, subtract the x's. This is beginning 2 minus -2. So it's 2 minus, take, -2, all squared, plus the second will be 4, take -1. So it's 4 take -1 squared. Okay? The 2 negatives in each of these brackets become pluses. So the next line will be the square root of 4 squared plus 5 squared, which is root 16 plus 25, which is 1, and it's 41, it's root 41. So this length here is square root of 41. Now, the next one here, try and find AB, so distance AB, with equal, you write down the formula again. Now this time we'll start, once again, we'll call this the beginning, and this is the end point. So it makes it easier that we keep this order of the points the same. So the first bracket is subtract the x's, so it's 2 take 3, so it's 2 take 3 squared. And the next one is 4 take -2. So it's plus 4 take -2. Don't put the bracket, and square it. The double negative, once again, becomes positive. So it equals, this is -1 squared, and this becomes 4 take -2 squared, that's plus 6 squared. Now, the -1 squared becomes -1 times -1, so it becomes positive, so we have no problems. That's 1 plus 36. And that's square root, so it's root 37. So that side's root 37. To find the perimeter, we need the last side. So this is distance, we'll go CB or BC, doesn't matter. We'll CB, will do. Distance CB will be the same as distance BC. And we're simply going to say, well, this time I'll have this up here as the beginning point and B as the end point. So once again, we've written down the formula. The first bracket will be squared plus the second bracket squared. So let's do the first bracket. So it's -2 take 3. So it's -2 take 3. The second is -1. -1 take -2. The double negative in the second bracket becomes a positive. So this will be -5 squared plus -1 plus 2 is -1 squared. It doesn't matter about those negatives because when you square them, they'll become positive. So this becomes 25 plus 1 all squared. Oops, sorry, let's start again. Square root. and then it becomes root 26. Okay. So the perimeter would finally equal root 41 plus root 26 plus root 37. And that's it in its exact form. None of those values can be simplified. But if you want that to 2 decimal places or 1 decimal places, we just pop it into our calculator and evaluate. Now, some of the questions you will be doing will be to show that certain triangles are isosceles. If any of these two numbers became out the same, say for instance that this value here, the 37 and the 26, if they were both root 37, then that would mean that this length here would equal that length there, and this would be an isosceles triangle. How do you know which two sides to choose? Well, you do a quick plot in your book, and then you say, okay, these two look the same.
Just an announcement before recess.
Okay, some other questions that you'll be doing will be something like this one here, which is a circle with a centre at the origin passes through the point 0, the circle origin passes the point root 2, root 3. Find the radius of the circle. So just doing a quick sketch on that, just having a look at what we need to do. This means that we've got a circle over here, and it has a radius, it's centred at the origin, and we have, there's a circle, and it passes through root 2, 7. Let's just put root 2 and 7, root 7 up here on this point up here. So therefore, that length there would be the radius. So we simply need to use the distance formula and find the distance between the origin, OO, and root 2, comma, root 7. Now don't forget, after you've done that, then you'll need to apply x squared plus y squared equals r squared to find the formula of the equation of the circle. Okay? So those are the type of questions that you're about to do. Other types of questions that could be asked will be proving something is a rhombus. If you're proving something is a rhombus, you need to prove 4 sides are the same. So you have to go, if this is A, B, C, and D, you prove that A and B and C and all these sides here are the same. If a line runs horizontally, you don't apply the distance formula, you can just simply count the number of units between the actual points. So if DC is a horizontal line, and this was here at -2, and this one here was at 3, then you know that the distance here would be 5. So if this point here was, so if they are horizontal lines, you just subtract the x values. The same thing if a vertical line is done. If this is up to a level of 4, and this is a level of 1, then we know the distance is 3. So you can do distance formula without, so distance between points without actually using distance formula if they are horizontal or vertical lines. If you need to prove that something is right angled, a triangle is right angled, okay, then if you find that this point here, A, B, and C, if we find this is 2 and this is 5, then this would have to be, this third line here would have to fit the Pythagorean triad. So this would have to be, C would have to be the square root of 5 squared plus 2 squared, which is root 29. So when you find distances, you will find one side and then the other, and then apply Pythagoras' theorem to find the other, and if it does fit, and if this is actually root 29, then we know we have a right angled triangle. So I want you now to take your time to do 7.1 in either the 2-unit or the 3-unit textbook. Thank you very much.